Yet another Bernoulli equation. So here we have a more interesting fraction here. It's n is 3/7. You know, it can be a positive integer, it can be a negative integer, it can be a fraction, it can be any fraction. Here we have 3/7. Right, so we have our n equals 3/7. So then our u substitution, again, is y to the 1 minus n. Okay, so 1 minus 3/7 is y to the 4/7. Want to find the derivative here, so u prime is equal to, okay, the 4/7 will drop down, y to the 4/7, 4/7 minus 1 is negative 3/7, so y to the negative 3/7 times y prime. We want to get y prime by itself, so let's see here. So multiply, we get 7/4 u prime, y to the 3/7. All right, equals y prime. We'll also need, y just by itself. So I have this u is equal to y to the 4/7. So let's multiply both sides by y to the 3/7. So u y to the 3/7 equals y to the 1. All right, 3/7 plus 4/7 is 7/7, y to the 1. All right, so then going back, we have our y prime plus y equals e to the x times y to the 3/7. So again, as usual, plug things in. So y prime, we exchange with the u prime, so that's 7/4 u prime y to the 3/7 plus, okay, the y we can exchange with the u to the 3/7, u times y to the 3/7 equals, I have e to the x still, and I have u, we just leave that alone, so y to the 3/7. All right, well, the 3/7, right, we can divide out, so we end up with 7/4 u prime plus u equals e to the x. It's not too terrible looking. Let's get it into standard form for integrating factor. So multiply everything by 4/7. So we get u prime plus 4/7 u equals 4/7 e to the x. All right, so our integrating factor, e indefinite integral of 4/7. All right, dx. Okay, that ends up being e to the 4/7 x. All right, so that's that. Here we go. So now e to the 4/7 x u prime plus 4/7 e to the 4/7 x times u equals, where'd it go here? 4/7 e to the 4/7. If I multiply these together, I have e to the x times e to the 4/7. So I think that ends up being e to the 11/7. And there's an x there still. All right, so reverse product rule. All right, so we've got e to the 4/7 times, x times u, the whole thing prime. Leave a space for my dx, leave a space for my integral, 4/7 e to the 11/7x. So now I can integrate both sides with respect to x. Okay, integral and derivative cancel. E to the 4/7 x u is equal to, all right, so let's see. So 4/7, the reciprocal will pop down, so I'll get times 7/11 times e to the 11/7x plus a constant. All right, so let's see, simplifying that a tad, the 7s will cancel. All right, let's go ahead and put the y back in at the same time. So I have e to the 4/7x. The u here was y to the 4/7. So y to the 4/7 equals, okay, 4/11 e to the 11/7x plus c. All right, let's multiply both sides by e to the negative 4/7 x. All right, so that ends up being y to the 4/7 equals, okay, 4/11 still, and I think that ends up just being e to the x. Yeah, pretty sure e to the x. Right, so 11 minus 4 gives you 7. 7 over 7, e to the x. And then I got my plus. Okay, this one isn't going to cancel, so constant e to the negative 4/7 x. All right, and then we take put everything to the 7/4 power. So then y is equal to 4 over 11 e to the x plus c e to the negative 4 over 7x all to the 7/4 power. And since that is a 4th root, we'll probably need the plus minus. We want to satisfy all the different initial conditions. Well, there we go. That one, even though that looked pretty bad with the e to the x actually, but yeah, we solved it. This is a Bernoulli equation. It's one of the not very many nonlinear differential equations that can be solved.